This is a video on the Hess's law questions that showed up on the worksheet. So the first question we're going to do is number 2. We're going to simply make note of the fact that 3SiO shows up on the product side and SiO shows up on the product side. So that tells us that we're going to keep this first reaction as is, left to right, but we're going to multiply it by 3. And then the second observation would be that the 2N2O appears on the product side, and 2N2O also appears on the product side. So that just means that everything is okay with the second reaction. So translation to that is that we're going to multiply the top reaction by 3, and that we're going to keep the second reaction as is, or we can indicate multiply by 1. And that just means that when we add up those delta H's, they will add up to 2023.75. The next question we're going to do is number 5. And in question number 5, all we are given is this balanced reaction. And that means that we have to go to the heat of formation chart and we have to look up substances. So the 3 substances that we need are calcium hydroxide and calcium oxide. And then it is important to note that in the reaction we were given, it is gaseous water, so it has to be this one, negative 241.8. So we're going to take those 3 and we're going to transfer the delta H's underneath the reaction. So these are the delta H's for each of the substances that we have in this question. So just to emphasize, this delta H right here is, sorry about that, this delta H right here is for calcium hydroxide, this one is for calcium oxide, and this one is for water vapor. So the next thing we want to simply make note of is that in the first case, on the reactant side, calcium hydroxide is not being formed, it is a reactant. So we're going to reverse that reaction. It's not a delta H formation, and we're going to make it be a positive 983.2. And then all we're going to do is add these numbers together to get an answer of 106.5 kilojoules. The next question we're going to do is number 6. And in question number 6, we're going to make the observation that the substance N2O5 is on the reactant side, and here it is on the product side with a coefficient of 2. That tells us we're going to flip the second reaction and multiply by 2. And then the other observation will be that the substance N2 in the third reaction is on the reactant side where we want it to be up here, but the coefficients differ, so we're going to keep that third reaction as is, and we're going to multiply that by 4 in order to get the coefficients to match up. And then the other observation we'll make is that there are things in the bottom 2 reactions that we don't want. So for example, we want to be able to get rid of this H2O. We want to get rid of this H2O by using the top H2O. So what that tells us is that we're going to have to flip the top reaction because we are flipping the second reaction, and we're going to have to get the coefficients of H2O to match up, and that means we're going to multiply the top reaction by 2. So if we sort of step back from this and say that this top reaction is going to be multiplied by negative 2, that the second reaction is going to be multiplied by negative 2, and that the third reaction is going to be multiplied by 4, then what we end up with is an overall answer of positive 28.4. Next question we're going to do is number 7. And in number 7, we have a word reaction, which means we need to write it, and we also need to predict some products. So this is the reaction that we're dealing with, where we know that each of these substances is, as we've indicated right here, that is to say, This is lead nitrate right here. We've got zinc oxide. Sorry about that. And we've got, one more time, we've got lead nitrate. Okay, there we go, lead nitrate. Let's hope this works. Zinc oxide. Sorry about those guys. And that in the N2 cases, I do think it's important to notice that this one right here has to be lead 2 oxide. So what that means is that we have to once again go to the heat of formation chart, and on the heat of formation chart, which is right here, and it is important to note that the lead oxide that we have to use is this one down here, lead 2 oxide, not the one that is at the top of the screen, lead 4 oxide. So in the end, that means that we're going to take each of those delta H's and we're going to transfer them over. So each of these right here represents the heats of formation. I probably should have also mentioned before that this reaction is balanced as it stands. But once again, because these are over here reactants in these two cases, what we are going to have to do to the heats formations of those two substances is we're going to have to reverse them. So that means that we're going to make this right here become a positive, we're going to make this become a positive, and then I'm simply going to add those together to get the overall answer of 101.4. Question that we're going to do is going to be question number 12. And in question number 12, I've given you a hint that you want to use the heat of combustion chart, which is what is on the back side of the heat of formation chart. So if you scroll to the back page, you'll notice that there are heats of combustion, specifically in this case for ethanol, and also for carbon monoxide. That's the other one that we're going to need. So once again, those two right there. So we're going to write a reaction which is going to be the reverse of the combustion reaction for ethanol. And we're going to do that because we want ethanol, in this case, to show up on the product side. So again, the observation that this right here is a product has to match up with the fact that what I write in this reaction must be a product. So that's important to understand. And then the second reaction I'm going to write is going to be the combustion reaction for carbon monoxide. I've gone ahead and doubled that value right there. And so once again, if you take a look at the heat of combustion chart, you'll notice that it is negative 283. So that means that actually what I need to be doing here in this bottom one is doubling this. And again, I've done that because of the observation that in this case, I need 2 carbon monoxides to match with the 2 carbon monoxides. And again, as I said before, I need the ethanol on the product side and the ethanol on the product side. And then if you do a simple addition of these reactions using the concept of Hess's law, it will work out and give you an overall answer of positive 800.8. Sorry, I forgot my change sign, right? My delta sign, sorry. Okay, those are all the Hess's law questions on that worksheet. There's going to be another video coming for the heat curves, Q equals mCp delta T. All right, thanks.